それではお時間になりましたので、オーストラリア・クイーンズランド州政府観光局、ケアンズと日本の大学生をつないだオンライン授業、グレートバリアリーフのサンゴから考える海を守るためにできること、開催させていただきます。私、本日進行を務めさせていただきます。共同 PR の浜辺と申します。どうぞよろしくお願いいたします。はい。それではまず最初にですね、クイーンズランド州政府観光局のポール・サマーズ局長より一言ご挨拶をいただきます。ポールさんお願いします。
はい、皆さんこんにちは。ポール・サマーズと申します。本日はご出席いただきまして誠にありがとうございます。皆さんもご存知の通り、近年の気候変動による環境への影響は様々なところで見られています。我々のクイーンズランド州にありますグレートバリアリーフについてもその白化現象が広く報道されていますが、局ではサンゴ礁の保全に関する情報や、そこで観光業が果たす役割などについて、発信しております。うちのウェブサイトなどを、発信しております。その中、我々としては、初めての、試み、となりますが、大学生の皆さんへのオンライン授業と称しまして、グレートバリアリーフについて保護するという観点から、クイーンズランド州にいる専門家に講義をしてもらう運びとなりました。これは、喜界島サンゴ礁科学研究所の渡辺先生、山崎先生の多大なるご協力によるもので、改めまして先生方お二人には厚く御礼を申し上げます。ありがとうございました。それでは、ここでクイーンズランド州について簡単ではありますが、ご紹介をさせていただきます。このまま日本語で話そうと思ったんですが、せっかくなので、私の流暢な英語でお話しさせていただきますね。Welcome to the Great Barrier Reef. But before that, here is a little refresher on Queensland. So Queensland is in the top northeast corner of Australia. It is the closest part of Australia to Japan. 日本から最も近いオーストラリアですね。It is only 7 hours flying time from Osaka or from Tokyo, and there is no jet lag. So it's very easy to enjoy after arriving into Queensland. The size of the state is huge. It is almost 5 times the size of Japan, but the population is very small, only 5 million people. Half of them live in Brisbane, which is the capital city. The number of visitors to Queensland from Japan before COVID-19 was almost 220,000 people a year, of which 35,000 were educational orientated in nature. 修学旅行とか語学研修の生徒さんで35,000人。Queensland has a long-standing relationship with Japan, going back more than 50 years with trade. And because of that, a lot of people in Queensland, a lot of high school students learn Japanese. More than 50% of all the foreign languages learnt in Queensland are Japanese students. So the most important tourism asset and arguably the most important natural asset that we have in Queensland is the Great Barrier Reef. As everyone knows, it is the largest and the longest reef in the world, 2,300 kilometers in length, roughly the same length as the Japanese archipelago. It is also the only living organism that can be seen by the naked eye from space. It's huge. That's a big number there. It's 746,000 times bigger than Tokyo Dome. So it's a very special place. And that's why UNESCO made it a natural World Heritage site in 1981. It has more than 1,000 islands, nearly 3,000 separate coral atolls, 600 species of coral, which is 1/3 of all the coral on the planet. It also has a lot of mangroves, which is more than 50% of the world's diversity. It has 200 bird species, 1,600 fish species, 30 species of whale and dolphin, and it has 6 of the world's 7 sea turtle species. And the best way to enjoy the Great Barrier Reef is from Cairns. Why? Because Cairns has an international airport right next to the city. So after you arrive in the early morning, you can catch a taxi or a bus and arrive in Cairns within 10 minutes. This is the center of the city here that you see in this photo. It's a very safe destination. There is a Japanese consulate in the city. There is a very good 24-hour medical center, a big hospital, and it also has a very large Japanese local population as well. So you're able to eat lots of Japanese food if you want. The population is still quite small, 160,000 people. So it's a very compact place, very friendly, and a village atmosphere in Cairns. In terms of climate, because it's subtropical, it's also summer all year round. 日本だったら、四季があるんですけれども、日本は、ケアンズは夏夏、めっちゃ夏、めっちゃ夏という感じです。はい。
ありがとうございます。サマーズ局長ありがとうございました。サマーズ局長からもお礼を言っていただきましたけれども、本日はですね、喜界島サンゴ礁科学研究所の渡辺先生と山崎先生の多大なるご協力のもと開催の運びとなりました。渡辺先生、どうぞよろしくお願いいたします。
はい、よろしくお願いします。はい、ですね、我々喜界島にですね、サンゴ礁の拠点ということで、研究と教育、そしてサンゴ礁の保全の拠点ということでありますけども、で今喜界島にはですね、日本からいろいろさまざまな分野の大学院生が集まって勉強しています。これも、先ほど紹介したグレートバリアリーフから言うと規模はだいぶ小さいですけども、サンゴ礁があって、でそのサンゴ礁が島を作って、でそこに人が住み、そして今いろいろな分野の学生が集まって学ぶ、それも僕から言わせたらサンゴ礁の恵みだと思っています。で今年皆さんコロナでですね、なかなか思うように海外旅行も行けないですし、海外行けない、そしてオーストラリアも行きたくても行けないということが続いてますけども、こうやってですねオンラインでつないでいただいて、いろいろなものをですね学んだり議論できたりするとすごく素晴らしい機会になるのかなと思います。よろしくお願いします。
ありがとうございます。続いて山崎敦子先生、本日はよろしくお願いいたします。
はい、よろしくお願いいたします。今日は貴重な機会をいただきありがとうございます。私たち小さい島で研究所を作ってサンゴ礁の研究をしてるんですけれども、グローバルに物事を考えるっていうのは常に意識しながら学生の皆さんも研究とか勉強に励んでいるので、こういうふうにオーストラリアクイーンズランドとつながる機会をいただけて本当にありがたいです。で、今回はですね、私たちの、研究所に、研究に来ている学生さんたちとか、あと大学の、研究室の他にですね、日本サンゴ礁学会の、会員の皆様にもご連絡をさせていただきまして、で、今回のテーマに興味を持った方が参加してくださっています。皆さんの活発な議論ができるように今日はすごく楽しみにしています。よろしくお願いいたします。
どうもありがとうございます。よろしくお願いいたします。はい。では早速ですね、本日の、講師のお二人いらっしゃいます講師の方々を、ポールさんからご紹介いただければと思います。
It's my great privileged to introduce the two speakers joining us from Cairns today, the two lecturers. We have Jamie Seymour, who is an associate professor at James Cook University, and who has a very distinguished career, particularly in the field of toxicology. And we also have joining him Ryan Donnelly, who is the CEO of the Reef Restoration Foundation. So over to you guys. They're out having a, where are they? There you are.
Are you rocking and rolling?
Yes, you're on camera.
Sorry. Oh, hi guys. Welcome to James Cook University. My name's Jamie Seymour, and I'm what's referred to as a toxinologist. So I work on venomous and dangerous animals. So if it bites or stings and is liable to kill you, then we've probably got it located somewhere here in the aquarium.
Whoa. So where are we at the moment? You're in the aquarium that's within James Cook University, is that correct?
Yeah, so we're in James Cook University. We're on its Cairns campus. So James Cook has about 4 or 5 campuses. The major one is in Townsville, which is just south of here. Then we have the one in Cairns and another large one in Singapore. So we're in the back of that now. So this is a research facility that I set up about probably 10 or 15 years ago. And basically it's got a freshwater, a marine side as well. And it's used for a variety of things, mainly for me to do research, to have the animals in here and do the research on the animals. And the other one is we do a lot of filming for commercial companies. So the BBC, National Geographic, Discovery Channel. So we've had Sir David Attenborough in here doing filming and things of that nature.
So you're friends with a lot of celebrities.
Yeah, I guess I have my fair share of celebrities that I know of. Yeah, so yeah, as I said, most of the people that have done stuff in Australia when they come to the marine environment end up at this facility at some stage, because we have most of the animals that they want to see. Plus, we work with a company called BioPixel who can film it all for them. So it's sort of a one-stop shop for everything if you want to do a documentary in the marine world in Australia.
Mm. And I understand that you also have some coral restoration facilities, or some coral restoration that is undergoing at the aquarium as well. Is that correct?
Yeah, so Ryan, who's going to chat to you later, runs a coral reef restoration project out off Fitzroy Island there. We're doing some work here looking at bits and pieces of basically for seagrass for restoration, but also coral. So if we wander over this way, so we have a series of tanks right throughout the aquarium. And this is one where we're doing some work on bleaching and coral bleaching. So it's, as everybody's heard, the Great Barrier Reef is in a major problem from a bleaching point of view. And what happens there is as the temperature rises, corals have an algae inside them or a plant. And as the temperature gets hot, the plants start to photosynthesize or produce lots and lots of energy. And it's much like a small child on red cordial or jelly beans or sugar. They get super excited and it starts to upset the coral. So the coral then get rid of the algae and they go white. So what we're interested in is what that actually does to their venom as well. So we've got a series of all these little corals in here and we can expose them to different conditions. So we can expose them to hot water, we can expose them to cold water, we can expose them to lots of UV radiation versus no UV radiation. And that all changes or stresses these algae out that are inside. So you can see here we've got a series of lights that we run down here. This particular light mimics the sunlight. So we can change that and we can drop it at different heights. And that will then increase the amount of UV that's going into the water. So we can stress or de-stress the corals depending on what we're doing. So this then also becomes very important, certainly at this time of year, because it's coral spawning time. So the corals spawn after the full moon in either November or December, depending on when the full moon is. So if the full moon falls early in November, the corals will spawn basically straight after that. If the full moon falls early in November, the corals won't spawn until December. If it falls late in November, they'll spawn in November. And if the full moon falls somewhere in the middle, like it did this year on the 16th of November, then some of the corals will spawn in November, some will spawn in December. So, yes. Oh, okay. So, and is that, you understand what I'm saying there, guys?
Yes, yes.
Okay.
So
cool.
in this tank here,
Yes.
just to make sure I understood, you are replicating a lot of conditions. So you've got UV radiation, which is the lights up there representing sunlight. So the effect of sunlight on coral.
Yes.
And in the same tank, is it a one temperature, or are you able to do, as you said, expose some of the corals to cooler temperatures, or is it one consistent temperature?
No, we can expose the corals in this tank to different temperatures. So if we can, I don't know whether or not you can get an image of this particular tank here. So if I move to this tank here, you can see that there are bright orange coral.
Yes.
They're the ones that have still got their zooxanthellae. You can see these browner ones over here.
Mm-hmm.
So these have been exposed to slightly warmer water. So they've lost their coral or lost their colour, and they're starting to kick out all those little algae. So you can see there the very big difference in the colour. So these ones here are bright orange, and these ones here are brown, and they're starting, you see that they're starting to go whitish. So if I grab that one and I grab one here,
Jamie, it's a little bit hard to hear you. So if you get a little bit closer to the microphone.
Yeah, I'm sort of pretty close to the microphone. I don't know if you can see the difference in the colour of those two. So this one here has been exposed to a high temperature, and this one hasn't. So this high temperature one here has lost all its algae, or starting to, and it will go white, whereas this one still has its algae, and it's still red in colour.
Right. Are they the same species?
Same species. They're actually clonal animals, so they're identical. So that's one of the reasons why we're using this. We can cut them in half, and then they'll regrow. So that one has come from this one here, where we've cut it in half, separated it, and then exposed this one to high temperatures, and this one has been in the normal area.
Thank you. And just for the record, which species is that?
Okay, this is a thing called Recordia, Recordia yuma. There's two species. There's Recordia florida, which is found in Florida, and then there's a species on the Great Barrier Reef called Recordia yuma, and that's the one that we're using here. As I said, we specifically work with this one because we can make them clonal, so we can cut them in half, so that any effect that we see is due to temperature or whatever we do to the coral, not due to a genetic difference between the corals.
Okay, that's very interesting.
So we'll move out this way to our bigger tank. So this is our outdoor tank, which down one end we have a series of coral. I'll just start feeding the fish a little bit, and hopefully they'll hopefully all come to the surface. But this is basically, we've got our coral reef set up in here, and our coral reef here spawns at exactly the same time as what the coral reef does out on the reef itself, which says to us that we've actually got all the conditions exactly right. Otherwise, this wouldn't happen. So coral spawning for the Great Barrier Reef occurred on about the 18th, 19th and 20th of this month. And our corals spawned about 2 nights ago in the tank here. So most of our corals in here were soft corals, not hard corals, but for a variety of reasons. They all spawned a couple of nights ago. So in this tank here, we've got all the corals, the fish, and we set this up so that it mimics what's going out on the reef. You can see a couple of little hammerhead sharks swimming through. And we do this because we can then actually go and film in here. So you can see, I don't know whether you'll be able to see, there's a stingray coming up into the middle of the shot there now.
Yes.
So we hand feed all our animals, and they're hand fed for a reason. So we make sure that everybody gets fed. Otherwise, if you didn't feed them, the things like the sharks wouldn't get fed, and they'd actually go around and eat the other animals that are in the tank. So I don't know whether you can pick up the hammerheads.
Yeah, we can see the hammerhead shark.
Yep, cool. So they're swimming around feeding at the moment. So this is mainly a filming tank for us, but we'll also do experiments and things in here as well. And the reason we can do that, as I said, is the system is set up that it mimics what's going out on the reef itself. Because what you need to remember is our entire system, we basically have one volume of water. So we don't take water in and send it out to the reef and then bring it back in. We have one volume of water. So we have to make sure our water is clean and we get rid of all the nasties and things that are in it so that it actually does what's supposed to happen out on in the reef itself. So what I want to do is I'm going to walk you around the corner here we've got some mangroves that we've set up, and I'll explain to you why we have mangroves in the system. So we're just going to walk around the corner here.
Jamie, the facility at the university,
yes,
is it something that students from Japan are able to visit? I mean, if someone from Japan wants to see you on site, is that possible?
Absolutely. That's one of the unique features of the facility, is that it's usually very unusual for a facility like this to allow people from outside of the university or even students as undergraduates to come and do research or be interactive with what goes on. So we regularly run tours for school kids, but we also, if we have overseas visiting students from universities and things of that nature, they often contact us. We're more than happy to show them the sorts of research that we're doing, and from those sorts of things. So it's something that we're really open about. We encourage people from outside to come and see what's going on, because unlike a normal aquarium that most people go to, which is set up for people to come and watch and do things of that nature, this is actually a full working research aquarium. So what happens on a daily basis, you can actually see us preparing the food, feeding the animals, running experiments, finding out what's going on, rather than just walking through and looking at the different animals.
That's great.
So this is our mangrove tank. So the one of the problems that we have, as I said, is we have this closed water system. So we need to make sure that our water is clean. So we run it through a whole series of filters and things to clean it all up. But it's still, you can't get rid of the nutrients out of the water that simple. So, for example, if we've got half a dozen sharks and lots of fish and we're feeding them, if they defecate into the tank, we need to remove all that byproduct. And this mangrove system does exactly that. So what we have is a very small mangrove system here. The water comes in over 7 hours and goes out over 7 hours, so it's tidal. But as the water comes in, the mangroves suck all the nutrients out of the water and use it for growth. So these trees are probably about 8 or 9 years old, but every 3 or 4 weeks, we cut the tops off them. So what happens is we keep cutting the tops and they keep growing. And for them to grow, they need to take nutrients out of the water. So this becomes if you will, a living filter for our entire system. So if I was to put it into perspective, if 10 was the best quality water we could get and 0 was water that everything died in, the water from our aquarium system comes in here at around about a 6 or a 7 and leaves here at about a 9.5 to 10. So it's an integral part of how we actually process all the biological hazards that are in the system. And it's a really good example for why mangroves are so important for the marine environment.
So if you want to have healthy coral, you need to have a healthy mangrove ecosystem.
Absolutely. The two go hand in hand. You often hear people say that mangroves are often the lungs of the ocean. That's not quite right. They're actually the kidneys. So they're responsible for pulling all the ocean bad things out of the water. So if you have, and you'll see this in areas where you get really good coral growth in places like Papua New Guinea and places like that, there are very strong mangrove systems associated with that. And we see that here when you go just north of Cairns. It's one of the few places where we refer to as the rainforest meets the reef. So you have the rainforest runs right down to the beach, the mangroves take off, and then you pick up the reef from there. So it's very unique from that point of view.
In Australia, are we doing a good job with our mangrove forests?
Compared to the rest of the world, yes, but overall, no. So if you look at other places in the world with mangroves, they're often cut down for firewood and things of that nature. Australia is making a concerted effort to conserve its mangroves, but we still need to do better. It's one of these things we're slowly catching up on, and we probably do it than most other places in the world, but we could still do a better job.
Excellent.
Okay, we're going to move over quickly to our turtles.
Oh, umigame.
Probably easier to go to.
広いですね。
We're going to run out of time. Sorry, guys. So these are our turtle tanks. So we do a lot of work with a group called the Cairns Turtle Rehabilitation Centre. So this is a Hawksbill turtle. Hopefully it'll swim around in a moment. It's got a radio tracker on its back. It came in. It had. Yeah, I don't know whether you can see that at the moment. Hopefully you'll swim around. Yeah, of course you'll swim around this side. Anyway. I don't know whether you can see. He's got a radio tracker.
Oh, he's not happy.
Well, he is actually really happy. He was sick. He had a fish hook in his throat. So he's just come from surgery and had that fish hook removed. And what they've done is they put a radio transmitter on him. So they're going to release him in about 2 or 3 days' time. He's been tagged, and that radio transmitter will send back to us as to where he is in the ocean. So you can, hopefully you can see now it's just coming up the surface there. So they'll stay in here until they're happy, and so he's been in for about a week or two now, until they're healthy. And when they're ready to be healthy and released, we'll release them again. So and release back into the wild.
Jamie, a quick question. Sorry.
Yes.
And I'm sorry if I have preempted you, but what is the relationship between sea turtles and coral?
That's a really good question. The relationship, and there's no direct relationship from a benefit from the point of view of corals and turtles, but there is for turtles versus corals. So the reason I was actually talking to Jenny, the lady that runs this, what you find is one of the major predators for turtles are tiger sharks. And during the day, the turtles can actually see the tiger sharks, but at night, what they do is they go and hide in the coral so that the tiger sharks can't actually find them. So there's a relationship there between that. So turtles, by and large, eat seagrass. So what you find is when we have large runoff from the land and we get lots of dirt and turbidity, the seagrass starts to die. The turtles don't have any food, and then the ecosystem itself then changes over that whole thing. So turtles, they're not what we refer to as a keystone species for the reef. And what I mean by that is that they're not a thing that drives what the reef does, but the reef and how it operates drives what the turtles do. Does that sort of make sense?
Yes, it does. Yes.
Yeah. So we've got a couple of turtles here. As I said, they come in, we look after them, and Jenny looks after them, get them back to a healthy state, and then we can release them again. And a lot of these guys come in with plastic bags in their stomach. So they normally would be eating jellyfish, but they can't tell the difference between a plastic bag and a jellyfish. And if they get a plastic bag into their stomach, that then impacts in their stomach and they can't pass it. They can't eat. They then get what's referred to as floater's disease, and they end up floating on the surface of the ocean and they can't dive down. And so they come in here. Jenny takes them to the medical facility, removes the plastic bags, and then hopefully we can release them again out into the wild. We might move inside. Very conscious of time. How are we going for time?
Yeah, we're doing okay, Jamie.
Okay. Okay, cool. All right. Well, we'll wander inside. So we have an outdoor portion to the aquarium, and we also have an indoor portion. So we'll walk you inside. Hopefully you can see over here on the side, this is our jellyfish tank. So,
jellyfish.
It's one of my major area of research is jellyfish. And I'm interested in the jellyfish from several points of view. One, it's a major problem from people getting stung and how we treat them. So I'm interested in that. But the other thing is that I do a lot of work on is looking for novel compounds from venoms. So what I mean by that is, can we find the next cure for cancer? from venoms in various animals. One of the jellyfish that we work with, we've taken part of that venom, which is non-toxic to humans, and we can actually cure rheumatoid arthritis in mice in around about 2 to 3 weeks. So
影の毒を使って関節炎を治そうとしてる。
関節
そう。
So when you start to think about what's here and what we don't know about these animals, we could actually find the next cure for cancer or any one of 100 different sort of arthritis or medical conditions. So we do a lot of work in those sorts of areas. If we wander over this way, hopefully you should be able to see here in the tank. This is the world's most venomous fish. It's a stonefish. Yep, stonefish. So that's the other thing that we do here. We supply all the venom for the production of anti-venom, stonefish, and box jellyfish. So
he doesn't look very happy.
No, they always look grumpy. What used to happen is they used to go out and catch a couple of hundred of these fish, kill them to extract the venom to make anti-venom. We decided we could do that in a better way. And so what we've done is we actually farm them. So we have maybe 50, 60 of them in the facility. And every 3 or 4 weeks, we milk them for their venom. And then we can actually send that venom off for the production of an anti-venom. So it means we've become greener as to what's going on. So, I don't know. I'm not sure how hungry this guy is, but we like to keep that shot on that. And we'll just see. I'm not sure how hungry he is.
Oh.
No, he's not going to. Just give me 30 seconds here. Hang on a sec.
Please don't die.
Just get a bit of food and see if we can actually make him feed.
なんていう名前でしたっけ、日本語の。
Yeah.
このストーンフィッシュ。
Oh, well, that was nice to try. Nope. Oh, well, it was worth trying. And this is one of our filming tanks as well, so we can set the whole thing up so we can film the animals here, so it actually looks like it's happening out on the reef. So that's one of the problems you have when you're making a documentary. If you're out on the reef, is you can't control the conditions. So, but again, stonefish for us, we extract the venom. Interestingly, one of the things that we've managed to extract from this venom that we're presently working on, again, is another novel compound. It seems that we're going to be able to use it to control intestinal parasites in humans. So presently you have to take chemicals that we manufacture to control worms and things in your gut. We actually think we found a compound out of these animals that will allow us to control worms and things in your gut as well. So, we might just wander this way.
その成分をこの、オニダルマオコゼイから取ろうとしているそうです。
すごいですね。
So this is our Nemo tank.
おー。
かわいい。
隠れ熊の実でしたっけ、
Hopefully they'll come out and feed when the food comes down, so you can see them coming out there now. So again, these are predominantly for filming, so we can actually film them. We've got to the stage where we know these guys will actually lay eggs, and they'll lay eggs every sort of 2 or 3 weeks, and then the eggs will hatch about 10 days after that. So it allows us to set the system up, and they can actually film that. And we were one of the self with Richard Fitzpatrick from here, some of the people that first that were ever able to film the eggs for the clownfish for hatching, because they hatch just on dark. And so you're never able to get it out in the field, but we're actually able to pick it up here within the system.
So Jamie, you said that you were the first in the world to successfully film the hatching from the clownfish.
Yes, yeah, we did that about probably about 15, 20 years ago. Richard Fitzpatrick sat down and did this. Yeah, we used some at that stage of the game. We were using the night vision goggles that the American Armed Forces were using. So we had to get special permission from the American Air Force to allow us to use those goggles and fit them to the front end of the camera. Because I said they hatch in the dark, so if you turn the lights on, everything stops.
Amazing.
If we come from this side, you can see there's more stonefish through here. We actually may be able to get those ones to feed. So hang on a tick.
Okay.
Squeeze in here. We'll either work or it won't, but we'll see.
山崎先生、日本にもこういうオニダルマ、オコゼっていますか？
はい、いますね。サンゴ礁で泳いで、もし間違えて踏まないようにするのが
そうですよね
大変ですね。
まさに。インスタ場合はしないけど。
Unfortunately, but again, these are more of the stonefish, different types that we have spaced right throughout the aquarium. And as I said, we milk those every couple of weeks to extract the venom so that we can produce or send it down for the end venom to be produced. So that basically stops people from dying when they've been stung from these things.
Fantastic.
Cool. All right. What we might also do, we'll wander up this road. I just want to show you a different set of jellyfish. So we'll come up this way. I have no idea whether they're going to show up in the tank. Oh, okay, great. You can see, so these are what's referred to as irukandji jellyfish. Yeah, the interesting thing is the tank that you see them in is designed and built by a Japanese company. We have all of these tanks are designed and built for us in Japan. And the main reason for that is nobody builds these tanks anywhere near as well as the Japanese do. And we would not be able to rear these animals without these types of tanks, as I said, which we get in from Japan.
So irukandji are extremely venomous to humans. Yeah.
Yeah. So that animal that you can see there.
Oh, we've lost you. Oh,
yeah, no, you should be back now. Yep. So if I put my finger in the shot, it'll give you some idea of how small they are. So if that animal came in contact with you, you'd be off to hospital. So in the grand scheme of things, they are probably the second most venomous jellyfish in the world.
クラゲの中では2番目に危険性のある種類、種類ですよね。We have 2 more minutes, Jamie.
I was going to say, we'll find Ryan.
Maybe 5.
はい、5 minutes. 5 minutes.
まあ、臨機応変に対応してるから。
すごい広いですね。
All right, well, I'm going to leave you here now. I'm going to leave you here now. We're going to hand you over to Ryan, who's going to talk to you about the coral restoration and the things they do out on the Great Barrier Reef.
Awesome.
It's an amazing system what he's doing out there. He's been at it for a little while now, and it's just absolutely mind-blowing as to what they're able to do now with growing corals and replace them back out of the reef. So I won't steal too much more of his thunder, so I'll hand him over to Ryan, and I'll hang around till the end in case there's some questions and things. So thank you for listening,
we've got some Q&A for you, so we'll talk to you later.
Okay, no problems. I'll hand you over to Ryan.
Sayonara.
Thank you so much. Thank you. はい、ではこの後は
Over to you, Ryan.
はい。サンゴ礁保護基金のライアン・ドネリーさんです。お願いします。
When you're ready, Ryan. I'm ready. Yep.
Hello, how are you?
Hello.
We can hear you.
No, we can hear you, Ryan. It's fine.
So who have I got?
This is Paul in Japan.
Hi, Paul.
How are you going? We can hear you, so hopefully you can hear us.
Yes, I'm just going to get the volume put up a little bit further. Let's get that volume. Right, that's better. Where are we?
I think you have a presentation that you were going to share.
I do indeed. Here it comes right now, I believe. Okay. All right. Well, I'm Ryan Donnelly. I'm the CEO of Reef Restoration Foundation. So we're a community-based not-for-profit organisation and a registered charity. On the Great Barrier Reef, we're quite unique because we're not commercially aligned with anyone. We're not aligned with a business, with a wealthy benefactor, or any government agencies. We're
Ryan,
fully independent.
I don't think we're seeing the presentation. It's not coming up on the screen. So
Okay.
you need to share it.
How's that? No?
Not yet.
It needs to be shared.
Have you been out on the reef in the last couple of days?
It's been about a week since I've been out on the reef, but my team has been out for the spawning this week.
Yes.
They're back today, so I haven't had a chance to debrief them, but I've seen some photographs. You can see it now?
We can. You just need to put it on slideshow in the bottom right. That's it. Yeah.
あと、山崎先生、ところどころ、日本語で補足い
Okay.
ただければと思います。
Over to
All
you
right.
again, Ryan.
All right. Thanks very much. So we formed in 2017. Prior to that, it wasn't even a permitted activity on the Great Barrier Reef. We adopted a method that was successful in the Caribbean. And what we work with is the fast-growing species that reproduce asexually. These are the cloning species, a little bit like what Jamie was talking about with the Recordia, but we use species from the Acroporidae family, which are the reef builders, the big producers of calcium carbonate, and they provide the structural complexity on reefs. Before I get into what we do so much, is I want to talk a little bit about the why we do it, what we do and how, but also then go into where I see the future going, the future for reefs and the future in the types of activities that we do. Now, this is our strategic plan, and we have a very strong focus on two key elements. One of them is reef restoration itself, and the other is community empowerment. Don't worry too much about those other columns. They're more for the running of the restoration program. It's guided by science. So we have a comprehensive science program, and including postgraduate degrees, and we collaborate with James Cook University, where we are now. And the community empowerment side of things involves the volunteer program, and most of the work is done by the volunteers from all compass points of our community. And we have a citizen science program because we can't afford to have scientists in the field, so we've got two that lead it, and we use the volunteers and others to collect the data for it. And we also do a lot of public speaking around schools and community groups and so on, and we focus on a very diverse audience through that program. So that's pretty well what Reef Restoration Foundation does. The sky's the limit with what we do. So I'll just get into now the why. Now, why do we do what we do? And I think you have to go back to around about the late 18th century and to around about the mid 19th century, the Industrial Revolution. Now, this is a critical turning point in history, because this was when new technology was made available and found really wide application, and it changed the course of history. It meant that production systems could be made more efficient. It meant that you could have electricity grids. It meant that you could have a modern, in those terms, manufacturing sector. But it did mean that we needed to burn coal, and it did mean that we transitioned away from burning timber for the sake of steel production. But it had a manifestation of changes to air quality, and that was a big thing. And what it did do was it made life a lot easier. And this is how the population of the world manifested. Now, this is extraordinary. This is a direct result from the Industrial Revolution back in the late 18th century. All of these people need to eat. All of these people need fresh potable water. They need fabrics for their clothing, and they need materials for their shelters. And this also gave rise to the growth of big cities, to the point now where 2/3 of the world's population live in cities. And we need to build the civic infrastructure around that. So we're basically in a feeding frenzy of production, and we have been for the last 200 years. And that production uses a lot of energy, and that energy has been gained from burning fossil fuels, including the invention of the internal combustion engine, which of course gave rise to the global reliance on oil. So how does that manifest in the environment? I'm sure you're all aware of all of this sort of stuff, so I'm going to keep it really, really simple. The greenhouse effect is certain gases, including carbon dioxide, nitrous oxide, and methane, that is naturally occurring in the atmosphere, and it reflects, it traps some of the sun's heat, and it keeps the Earth at a habitable level. Otherwise, it wouldn't support life on Earth for humans. What we've done with pumping the gases into the air from the production frenzy that we've been in for the last couple of hundred years, and the great population growth that we've seen, and the modification of the landscape and this sort of thing, is that we've seen the Earth warm. We've enhanced the greenhouse effect, and it's that enhanced greenhouse effect that gives rise to global warming, and then changes the patterns of weather and climate. So this is where we start to understand the changes, and the way this is manifested is in changing rainfall patterns. So we see rainfall contract in some areas and expand in other areas. So we start to see the proliferation of drought in some areas and flood in other. We see crop failure. And last year in Australia, we had the most intense fire season we've ever seen. You probably saw it on the news. It also results in disconnected habitat. When you look at the old polar bear there in the middle there, his habitat is disappearing in the Arctic, because that's much of the Arctic is on top of water. It's not a land mass. So this starts to cause major problems for humanity, particularly as we have the population continues to grow in certain parts of the world, and we see water contracting in places where water was readily available. And so it gives rise to all sorts of things like the migration of humanity to different parts of the world. So it has fairly significant ramifications from that adoption of new technology back 200 years ago, because it had a widespread application of that technology. This is relevant because we're in a similar sort of stage in human development now. So how does this affect the Great Barrier Reef? Well, first of all, I'd say about the Great Barrier Reef is that it is a very large place, very large indeed. It's very similar in size to Japan. I think Japan is 377,000 square kilometres. We're here at 344,000. Importantly, it spans 14 degrees of latitude. It's longitudinally elongated. That spanning 14 degrees of latitude just gives it enormous resilience, because there is a discernible temperature gradient from north to south, and the distance of the reef from the shore just means that you have an enormous body of habitats and enormous biodiversity, and that in itself gives it enormous strength, because each one of those species has a function to perform to make a well-rounded ecosystem. So I'll just go into a little bit about how the enhanced greenhouse effect has manifested on the Great Barrier Reef. And the slide on the large picture on the slide there is the Category 4 and 5 cyclones between 2005 and 2015. Now, we haven't seen an increase in the frequency of cyclones. So what we have done is seen an increase in the frequency of the big ones. Now, these are the ones that tear the roofs off houses, and they do a lot of physical damage to coral reefs. They do this all over the world, but this is obviously the Great Barrier Reef example. I think the important thing about this slide, though, is that you can see that as big as the Great Barrier Reef is, none of it is unaffected by these cyclones. You'll see the cyclone Hamish there from 2009. It just ran the whole length of the Great Barrier Reef. Didn't cross the coast. It just ran the length of the Great Barrier Reef and caused enormous damage. The other thing, the other element there is crown thorn starfish. Now, these are a natural part of the ecology on the Great Barrier Reef, but they will breed in infestation populations when the certain parameters come together, when the breeding conditions are right. A key part of that is elevated sea surface temperatures and the presence of nutrient enrichment, typically of dissolved inorganic nitrogen from sugarcane that we have a lot of in the catchment areas of the Great Barrier Reef, and that increases primary productivity in the face of sunlight for photosynthesis, and you get a proliferation of the baby crown thorn starfish and an increased larval survival rate. So once they start to grow, they've got a very few predators of crown thorn starfish to manage ordinary populations. But when they're in infestations, they go into very large populations indeed, and they eat coral. And the coral that they eat are typically the fast-growing corals from the Acroporidae family, the reef builders, the ones that produce the calcium carbonate and the critical structural complexity in the habitat that supports all the wildlife that live on the Great Barrier Reef. So these are a very important pest to get a control on, and they are a direct result of having infestations due to elevated sea surface temperatures and runoff from land. We can change the runoff from land through farm practice change. Changing the sea surface temperature is a global problem that needs to be addressed by all countries. And of course, the third one is coral bleaching. Now, Jamie told you about the mechanics of coral bleaching, but what I would say about that is that the first reported mass coral bleaching on the Great Barrier Reef was 1982, which means it's a relatively recent phenomenon. And the frequency and geographical extent of coral bleaching events is getting larger, and very large indeed. In 2016, areas north of where we are here in Cairns, all the way up to the very tip of the northern tip of Australia, suffered enormous coral bleaching and quite a higher amount of mortality. It could have been a lot worse, because where there was a Cyclone Winston that went over the Fiji Islands, and it swung around and it brought a rain depression with it and cooled things down. Otherwise, much more of the Great Barrier Reef would have been affected. Now, coral bleaching isn't a death sentence per se. It's caused by exposure, prolonged exposure to elevated sea surface temperatures. And if those conditions persist, mortality can result. But if those conditions moderate, you have a big rainfall event, or it becomes cloudy for a few days and the sea temperatures cool, or we get a break from a radiance from the sun, then the corals will take another algal symbiont into its tissue and it'll survive. So it's not a death sentence, but it certainly can be. Every time we have a new bleaching event, it seems to be bigger than the last one. And that's a big problem for us. So let's get down into the tin tacks of coral reefs themselves. Now, like all other ecosystems on the planet that have species diversity, you have some species that are fast growing, opportunistic. They might have a lot of babies. They're brightly coloured. They respond first after disturbance. So they're the ones that get knocked over first in a disturbance at one end of the spectrum, and then up the other end of the spectrum, you got the specialists, the slow-growing, long-lived species. If you looked at it in terms of The animal kingdom, you'd have elephants up the specialist end, and it's not an animal, it's an insect, but you'd say, as a grasshopper or a locust would be down the other end. So the weeds and the trees is how I like to refer to them. It's on a spectrum, right? So you've got species there that are in between those two extremes, but this is what you've got at either end of it. Now, the reason I've put this up is quite important. That is because, as we're seeing with the effects of the enhanced greenhouse effect, raising the sea surface temperatures, this is the common theme, elevated sea surface temperatures, then the first things that come back are these early stage recovery species, right? These are the acropora corals. You see the plating and branching growth habits of these species, and they create habitats. We call that structural complexity. It's very important. They excrete a lot of calcium carbonate. They're reef builders, but these are the first ones to get knocked over in a disturbance event. They're fragile. They get smashed up in cyclones. They get eaten by counterthorn starfish, and they're shallow water species, so they're the most susceptible to bleaching. They're the first ones to come back after all those things, but they don't give you the diversity of habitat that you need on a fully healthy coral reef. The importance of the increasing frequency of these disturbance events is that it limits the recovery time in between the disturbance events for the slow-growing species. That's when you start to lose biodiversity. And biodiversity is absolutely critical because over millions of years, the species that we've got in front of us today are survivalists. These are the species that have survived the evolution to the point we're at now, and they all have a role to perform, right? So you start to take species out of the population through the loss of biodiversity, you start to lose functionality on the reef, and it makes it more susceptible to things like disease or takeover by algae or a disproportionate population of herbivorous fishes or lower trophic level prey species of fish and invertebrates. It puts the ecosystem out of balance. Now these species here are the big specialists that I refer to. Now these are not asexual reproducers. These are not the cloning species. These are big producers of sperm and eggs for the annual spawning season that we're in right now. So you start to lose these species off different reefs, then you start to have difficulty, you diminish the capacity of a reef to self-feed itself, to replenish itself. Because like right now, this week it's been, and as Jamie said, it might be that this is a split spawning season between November and December, but my team has been at sea this week, and they've been reporting that they've had good results from spawning in different locations off Cairns. It's been sensational. Been really fortunate to have this. This is one of the great phenomenons in the sea, and we're very fortunate here in Cairns, and I hope that when you come here, you're able to see this. That the reef is actually quite close in Cairns. You can be at the reef within 3/4 of an hour on a boat that holds lots of people. So you're capable to see it. It does only happen at night though. That's the only problem. So with all that in mind, all the why, this is what reef restoration is all about. Now, as a discipline, it's been around for about 30 years, and it grew out of the terrible practice in the likes of Indonesia of dynamite fishing, where you've had communities that have live in the far-flung archipelago of the islands there in Indonesia that have lived by subsistence means for generations, and in recent decades have made the transition to the cash economy, sometimes as a result of the church paying a tithe to the church in money where they haven't used money previously. And I've worked there in the Solomon Islands and New Guinea and around the place. I've seen this transition firsthand, and it can have devastating effects on the environment that supports the the nutritional needs of people in the islands. Dynamite fishing is a way to get cash from the markets, and I've seen big schools of fish, all exactly the same size in fish markets in Indonesia, that have been caught by dynamite, and I've been diving in the Raja Ampat Islands, and I've heard the dynamite go off. It's very disconcerting. So in those areas, people began using their own innovation and think, okay, well, what are we going to do to regrow this reef? So that's where it all began. It's been used also in places like the South Seychelles, Maldives. In the Caribbean, it's been around for about 20 years. They've got very poor species diversity on their reefs in the Caribbean, and they've got poor fisheries management. That's all I can say about it, is just poor fisheries management. So reef restoration on the Great Barrier Reef, it only became a permitted activity in 2017. Prior to that, it was the management policy in the aftermath of a disturbance event like a cyclone, or whether it was a coral bleaching event or a ganothorn starfish, to keep reef users away and let nature take its course and let it recover in that natural cycle. But of course, we've seen the increased prevalence of the large cyclones, increased prevalence now of ganothorn starfish infestations, and more recently with large coral bleaching events. That they've changed the policy, and they will enable an intervention. So my organisation actually formed as an organisation before it was a permitted activity. We jumped the gun and took a bit of a bet, and as it turned out, it was a good bet to take, and we secured the first permit. But most importantly, this is around making reefs healthy and accelerating the natural process of recovery to build its resilience for the places that we love. They're very site-based, and they're by no means an alternative to action on climate change. That's the most important thing we can do. So, yeah, Reef Restoration Foundation, we formed prior to the first permit. We landed that first permit. Our model, and I'm only going through this because I think there is scope for people who come to Cairns to study to get involved. We focus very much on a site stewardship approach. So we work in partnership with tourism operators. They take us to the sites. We rebuild damaged areas of their sites, and they are able to demonstrate to their market that their custodial approach. So we work in partnership. It's a genuine partnership approach. And the most important thing about it is we're not government funded. All our resources come from donations from businesses primarily, and also from individuals. And we use an army of volunteers. Cairns is the home of scuba diving. It's also every second person on the street's a marine biologist, churned out from where I am here in James Cook University. So when it comes to finding volunteers to help you with diving work, it's very easy in Cairns. I'm going to be adopting a complementary method very soon that will create opportunities for non-divers as well, which is very important because I want our community education program to be able to touch the hearts and minds of everyone in the community, not just divers and the people that typically interact with things on a day-to-day basis. So this is how we do it. This is a photo from the Caribbean, from Reef Renewal International. These are the people that we consulted to get a method that we thought would be best for our purposes here. We chose this method because it's visible, and we could then go to a tourism operator and say, look, you can show to your customers and to your market the work that you're doing, and it's big and bold, and you'll be able to point it out and demonstrate it. What this does show, though, is those tiny fragments on the left-hand side. 1 year later, they've turned into these colonies. The reason they're so big is once they're up in the water column like that, they're free from parasites, they're free from predators, and they're free from only being able to grow in one direction. They're able to grow spherically, and because they're up in the water column, they got greater access to sunlight, more prolonged access to sunlight for photosynthesis. And the experience is they grow about 3 times faster than they do on the reef. And now this is where we achieve accelerated recovery. And that's what it's all about. If there's going to be a shortened period between disturbance events for recovery to take place, the idea is to speed the recovery up. So you create the surface area for when corals spawn, when those big corals I showed you, when they spawn, those little fertilized gametes have somewhere to settle, and they'll settle on those staghorn corals. It's a very important little principle, I guess you'd call it in reef restoration, is just speed things up. And so we use fast-growing species such that the spawn of the slow-growing species can settle on them. So how do we do it? It's a fairly simple process. There's things we call corals of opportunity. What they are basically is pieces of coral that have broken off mature colonies just through wave action. Now, these are typically from the Acroporidae family, so the fast-growing species that create the structural complexity and the calcium carbonate to build the reefs. Those pieces will lay around on the seafloor until they die. They'll be attacked by parasites like flatworms. They won't be affixed to a hard substrate. They'll roll around. They won't grow. They'll die. So what we do is we retrieve them and we breathe life back into them. And we put them up we'll cut them to a certain size and configuration and put them up in the trees so they get healthy, away from parasites and predators, into the sunlight. They'll get healthy and then they'll grow. And after about 6 months, thereabouts, typically 6 to 9 months, depending on the species, we'll put them back out on the reef, and that's where they become. They will create the habitat and the function. They'll play their function in the ecosystem. This last thing is when we take the corals off the trees, we only take about 3/4 of the corals off the tree and leave the other quarter, because the other quarter will get bigger, and we'll trim those and then repopulate the tree. This is why we get into a self-sustaining cycle. So we don't have to swim around collecting corals of opportunity all the time, because you run out of those. This way I call it a self-licking ice cream. It looks after itself. So this is one little piece of coral up in the top left-hand corner. We put it up on the tree for, I think this one was 6 months. When we took it down, we put it on this grid, and this is how we work out the rate of growth, because we know that the time period that's gone by. So we put it on there, and we use a computer package to measure the growth. The third one is when it's been planted out on the reef, and the fourth one is the same piece as in the top left-hand corner. That's a period of 2 years. And I can tell you, I swam over this piece about maybe 6 months ago, and it's every bit of a metre in diameter now. And we've got thousands of these. So this is the difference that it makes. You go from a very small piece that's been cut with a pair of tin snips. You put it up in a tree and it grows beautifully. You cement it back out on a nice hard substrate like that, and it takes off. And you do that thousands of times over, and you start to build some serious cryptic habitat that supports myriad species of invertebrates and small vertebrates, and it attracts larger fish and then the predatorial species around it. You start to build a full suite of species around that reef. I think probably for me the most important and the most enjoyable aspect of the whole thing, though, is, remember I said that there's 2 main components. One's reef restoration, the other one's community empowerment. I love the volunteer program. Yeah, like the community around us here in Cairns, it's culturally diverse. Our small army of volunteers, which is about 60, each one of those people are rescue certified divers. Once we get to a point where we don't need divers, which I hope is going to be early in 2022, that 60 will grow to 600, because not everyone's a rescue certified diver. That's the 3rd level of dive certification. So what I've done is secured a nice operational headquarters there on Fitzroy Island, which is a beautiful little tropical island, only 45 minutes away from Cairns. I bought a little boat there that runs off a solar panel on the roof that charges a lithium-ion battery, and that in turn runs an electric motor. So we're able to get 8 divers around the bay and not generate a single greenhouse gas. And it's photogenic and it takes 8 people, and I love it. Most importantly, it's a volunteer program that people are falling over themselves to be a part of. We have lots of different evenings and events, and when you go out with the volunteers, you get twice as much work done as if you went out with the crew that you're paying. I don't understand it, but it works that way. And you have about 5 times as much fun.
Thank
Okay,
you.
so these are our sites. These are our sites. It's unfortunate that they're so beautiful. Got to remind myself every day just how beautiful Cairns is and just how beautiful my workplaces are. So Fitzroy Island, Moore Reef and Hastings Reef, you just can't get any better than that. So what happens in the future? This is a rapidly evolving discipline. Where it's been occurring in the likes of Indonesia, the Maldives, Seychelles and so on, it's been a scale of a tennis court. But now that we're seeing the manifestations of the enhanced greenhouse effect, resources are being thrown at developing this discipline. Things like larval rearing, which intervenes in the life cycle of a coral at a time when background mortality is at its highest. Governments are investing in accelerated evolution here in Australia, down in Townsville in Ames. That's what they're up to. The idea is for large-scale deployment, but there will always be a role for local site stewardship. But it is an exciting future. Now, the reason I started with the Industrial Revolution is because we are now in the next Industrial Revolution. It's the first one applied new technology, and it found an application for that new technology in all walks of life. It came with external costs of production that were significant. The new Industrial Revolution will do exactly the same in terms of the development of new technology applied and applied and applied, but it won't have the external costs of production that we see in pollution and changes to the environment. To me, it gives me great hope and optimism, not great confidence, because people have got to work together and we've got a history of not working together all that well on a global scale, but you can't help but be optimistic about it, and that's exactly where I stand. So when you come to Cairns, you'll find a very laid-back country, a very laid-back tropical city, populated by people who are nature lovers and interact with their environment. And you'll find plenty of opportunities to participate, and I urge you to do that. And most importantly, we're a very modest lot. This is me, believe it or not. That's all I've got. Thanks very much, guys. And we'll get Jamie back in and we'll answer some questions.
Hey.
Ryan, can you hear me? It's
Yes.
Paul from Tourism Events Queensland. Just before we switch to both of you, we've had 2 questions in the chat, probably best answered by yourself. The first one is, you mentioned the staghorn coral that you're using predominantly. Are you using any other species of coral at the moment?
Staghorn corals are a suite of species, and we use primarily species from the Acroporidae family. Now that's the largest family of corals in the whole taxonomic tree, and once it's reclassified at molecular level, it's expected that family will double in size. So there's a lot of genetic diversity. When you use what we call corals of opportunity, you use a broader range of species, but because they break off with wave action, they're typically branching or plating. So we're operating at around about 30 species, but we're not looking to create species diversity from our planting. We're looking to create the environment for fertilized gametes to settle on after a spawning event.
Right. the other question was, with the coral planting program that you've introduced, is it possible for ordinary citizens to pay a contribution to the program? And if so, how much?
They can make donations of up to $1 million.
Perhaps a more modest donation, but do you have a fee for one seedling, for example?
Yes, what we do on our website, which is reefrestorationfoundation.org, you'll see a donation tab, and you can do adopt a coral for $50, or you can just customize any amount. You can adopt or tend a coral branch for, I think, $500. A tree for $10,000. These are for businesses primarily.
Right.
The popular one for individuals is adopt a coral, and that's $50. But if you want to give $5, that's fine too. And $1 million is also fine.
So $5 is the minimum, did you say?
No, well, we have $50 is the adopt a coral, but you can customize a donation to whatever figure you like. That's
understood.
You can do that on the website.
Okay.
Are you able to?
Okay.
Thank you.
Any other questions?
Yeah, there is. We're just trying to catch up a little bit.
We have a question before.
There's one more question here. This one here.
Sure.
So when you actually plant the coral, what impact does it have on the growth of the existing corals in the site in terms of light and nutrients?
Look, typically we're rehabilitating places that don't have corals on them. That's the whole reason we're there. If we're planting corals in amongst a bunch of other corals, then we're pretty well doing the wrong thing. There's a
Okay. じゃあ、サンゴを移植するときに、なるべく周りのサンゴが、生息してないところを、選んでいるということですね。はい。
はい。あと、事前に、参加者の方から質問いただいてますので、まず最初に日本語でちょっと読み上げて、サマーズさんにちょっと英語でケアンズの方に送っていただきたいと思います。最初の質問です。サンゴ礁そのものの研究とサンゴ礁の保全とではしばしば考えが対立することもあると思うのですが、この2つの研究分野において独立性を維持することと強く関わりを持つことではどちらが良いでしょうか。質問いただきました。
Okay, this is a question that we received previously. I know the research of the coral reef itself often is opposed to coral reef restoration work, but which do you think should be better? These two researchers stand alone respectively, or are they connected strongly?
I think you need to take a multi-pronged approach to building resilience on coral reefs. You need global action on climate change. That's probably the most important thing. But there's things that you can do at an individual level and at a community level to build the resilience of the places that you love. If you're in the rainforest, you can go and plant trees. If you're into production that doesn't impact the Great Barrier Reef, you can plant trees along waterways. If you like coral reefs, you can go and hasten that process of recovery and try and maintain the biodiversity on that particular reef. Reef restoration at the scale that it's conducted now doesn't change the Great Barrier Reef. What it does do, though, is it gives something tangible that communities can get involved in, and that the technology that underpins reef restoration is developing very, very quickly. And the methods that are deployed today are unlikely to be deployed in 5 years' time. But we need to build the framework and the architecture so that we can adopt the new technologies and get it out there. It's no good waiting until the technology is developed before we start doing stuff.
Okay. So your But basically, you're building the base for future coral restoration technology. It will evolve from here on.
Absolutely, and there's things that we can do now. We don't need to wait until assisted evolution is developed, and corals are taught to select thermally tolerant zooxanthellae. This is all futuristic, but we're not there yet. But there's things that we can do now, and we should do them.
Excellent. The question.
The other interesting.
Sorry. Yes.
The other interesting thing to think about here, to put this into perspective, is the Great Barrier Reef is the only living thing you can see from space.
Yes.
But it's built up of billions and billions and billions of individual polyps. So from what Ryan's saying, you can do things at a big level, like global companies changing carbon offset and things of that nature. But you as an individual are actually an individual coral polyp. And together, if we all do our own little bit, we can have a huge effect. So I think that's important to remember. You pitch it in the same way that the corals work. Each individual little coral polyp does its little tiny bit, which in the grand scheme of things isn't much, but you put it all together and it has a big effect.
Right. A bit like me putting my 500 yen in my piggy bank every night. Yes.
Exactly.
Okay, next question. Actually, we have one in the chat from
Then maybe
the people
the
at
students
KIKAI.
can ask directly.
Yes.
お願いします。
They're from KIKAI Institute. 誰ですか？桃江か？誰か？
So thank you for your presentation. I have two questions to ask. So I remember there's a slide showing the step 1, step 2, step 4, step 3. I mean for the tree frame. And I wonder how far away the site where collecting corals and site where to put on tree. How far away are they?
So Ryan, it's a very good question. If I can just rephrase the question. You showed us the slide where you had the 4 steps. So the first site was where you collected the coral. And then the second photograph was where you attached the collected coral onto the tree. The question was, how do you choose the species to go on that tree, and how far away?
Yes, thank you.
Because we're using these things, these pieces that are broken away from mature colonies, they tend to be, in a limited range of species, because they're typically branching or plating species, so the fast-growing Acroporidae family corals. They break away because they're fast-growing and they're less dense. So it's a limited range of species, but our nurseries are where the outplanting site is. So we'll collect the corals of opportunity, take them to the shallows, trim them, and make sure that we've got the healthiest specimens that we can, and we cut them to a size that retains enough metabolism in the coral piece, so enough polyps in the colony, and generally cut them so that they have a rosette, multiple growth points, and then they'll go up in the trees, and the trees are right there. So we might swim them to the shore and sit in the shallows in a metre of water, but then we'll swim straight back out to the nursery, which is 100 metres away.
So it's not a great distance at all. We're just talking about a couple of 100 metres at most, yes?
Oh, that's right. The operation that we based our operation on in the Caribbean, they sometimes have to transport their corals 120 miles, so 180 kilometres or something like that in Bonaire. Whereas we don't have that issue.
Okay, thank you. Good question too. Thank you very much.
Yeah, I have one question. Can I ask?
Oh, 欲張りじゃないですか。
Sorry for that.
Go ahead.
asking, how do you choose which coral species to collect for the tree plants? Are there any rules or which species do you choose? Because I wonder if only one species you choose, it makes other species difficult to grow. I'm not sure. But yeah, that is my question.
Yeah, are we sort of placing too much preponderance on the staghorn coral, I think is what she's asking.
The reason we use the branching corals and the plating corals is that they're fast growing, and we're looking to establish cryptic habitat, a structural complexity, and we're looking to create space for fertilized gametes of all species from a spawning event to settle on. Right, so by using the fast growing species, the weeds on my little continuum there, we're able to accelerate that natural process of recovery, which is the whole point of the exercise.
Thank you very much.
You're welcome.
We better move to the next question. よろしいですか？
ちょっと時間が迫ってきておりまして、一つだけじゃあ、
ですか？
どうしますか？そちらしますか？
これ
はい、今年の報告で、グレートバリアリーフで、回復の兆候が、見られているとありました。グレートバリアリーフの保護回復のために何百億もの投資を国として実施していますが、政府の介入による効果は大きいのでしょうか？また具体的にどのような保護や回復が行われていますか？
Very good question. I found recently a report on signs of coral reef recovery on the Great Barrier Reef this year and noticed that the Australian government was investing significantly towards conservation and restoration. Has this governmental intervention had any profound effect so far? Also, I would like to know what specific activities are being undertaken for the conservation and restoration with this funding.
Well, this is something that I've been involved with for many, many years, and something I was in a meeting with this morning. It's to do with catchment management and the improvement of water quality that flows to the Great Barrier Reef. So there's been many, many hundreds of millions of dollars invested over the last 20 to 25 years for the improvement of water quality flowing from the adjacent catchments to the Great Barrier Reef, much of which has been matched dollar for dollar by farmers themselves. We have a lot of areas, particularly in the north of the state, I suppose, but it's also in the south of the state, very high intensity seasonal rainfall. And we've got a large traditional cropping of bananas and sugarcane. And a lot of the farming practices over the years have improved out of sight that comes from that investment. And to improve the export of things like dissolved inorganic nitrogen, the export of photosystem 2 pesticides, which is typically a herbicide, so that damages seagrass beds, and also even the algal symbiont in corals. And we've seen large investment in amelioration of gully erosion through grazing practices in some of the larger catchments. But that investment is, look, it's starting to pay dividends, but the fact is those crops are not high value crops, and I think that's the problem with it. Investment in the investment that's required in on-farm practices in those things are not rewarded by high prices for those crops. We're effectively producing crops that are probably best left to Philippines and Brazil, and even India, where we're producing low quality crops on high quality parcels of land. But in terms of the uptick in coral cover that you would have seen in the report that came from the Australian Institute of Marine Science, earlier this year. That's a study of mid-shelf reefs that's been going for about 30 years. And what it's shown over that period is that coral cover has declined by about 50%, but it's not a linear decline. When there's a gap between disturbance events, it recovers. This is what it does. It's forever in a cycle of disturbance and recovery. So if the ecosystem gets a break from cyclones and coral bleaching events, bountiful and starfish infestations, coral cover increases. And that's where we've been for the last 5 years. There was a bleaching event in 2020 last year, but it was in a very specific area of coastal areas south of Mackay, so nowhere near here.
I'm afraid we've run out of time, but we do have some other questions. So if it's okay with both of you, we might send them through to you, and you can answer them if that's okay. Not too many. Yeah. There's about 5 or 6 here. Is that okay?
Absolutely.
Thank you so much.
ありがとうございます。たくさん事前に質問いただいてますが、ちょっと時間の関係で今ここで回答できないので、追って皆さんにご回答、お送りしたいと思ってます。ありがとうございます。はい。
So thank you both for your precious time today. It's been very, very
はい、山崎先生の、はい、山崎先生の方から生徒さんにコメントいくつかいただけると嬉しいです。はい。どなたか
今聞こえますか？
はい、聞こえます。
はい、そしたら今日の授業の感想を言ってもらおうかなと思います。津田くんどうですか？
はい、
はい。
すいません。すごいいろいろ内容。日本語で大丈夫ですかね？ちょっと英語自信なくて。英語の方がいいですか？
日本語でいいですよ。
わかりました。そうですね。いろいろ環境とかそういう話をいただいて、すごい一番その興味深いなって思ったのが、その回復っていうのが相対的なものだっていうのがすごい僕の中で印象に残って、じゃあそもそもその回復とは何なんだろうってちょっと考えるいいきっかけになったので、そうですね、今も自分もサンゴとかに関わっていく中で、何か起こった時の回復とは何なのかっていうのを考えながらやっていけたらなと思います。ありがとうございました。
ありがとうございます。
That was Kazutada Tsuda, and he said his main takeaway from today is that coral recovery is not something that is one element, but is something that involves the whole holistic environment, and he would like to remember that going forward.
He's quite right. Well said.
ありがとうございます。もう一方いらっしゃいますか？
はい。じゃあトキさんどうですか？
音声聞こえますか？
はい、聞こえます。
ありがとうございます。北海道大学の小山時です。お話聞いてて、今いろんな日本もそうですけど、いろんな場所でサンゴが危機的状況で、それが人々の生活にまで影響を与えてるって言われますけど、単にそれをリカバーしていくというか回復していくって言っても、まずサイエンスの部分から具体的な方法っていうか、そこへのアプローチもしなきゃいけないし、その政策の部分にも人々を介入していく、一般の市民のボランティアの人たちが介入できるぐらいの力を持っていく体制を作らなきゃいけないっていうのが分かって、サイエンスとその政治両方の部分からのアプローチっていうのが必要だし、それが具体的にグレートバリアリーフではできてるんだなっていうのが驚きで、日本ではまだまだそこまで及んでないのかなっていうのを、人がそこまで介入できてないのかなっていうのをすごく遅れを感じました。はい、ありがとうございます。
ありがとうございます。
That was Miss Koyama from Hokkaido University, and she was quite surprised that in Australia we were in the early stages of developing a successful framework where there is science, where there is policy with the politicians, as well as the involvement of everyday citizens. So to see that intervention and that collaboration was her main takeout today.
Right.
ありがとうございました。ちょっとお時間、終了で時間3時半ということで、少しだけちょっと過ぎてしまったんですけれども、非常に時間が過ぎるのがあっという間に感じるほど充実したケアンズから、講義をお送りいただきまして、大変感謝しております。渡辺先生、山崎先生もどうもありがとうございました。
ありがとうございました。
ありがとうございます。またね、今回だけに限らず、今後も、またシリーズ化して、こういった機会ができればいいなと思ってます。ポルさん。
ぜひぜひ、
はい、
ぜひ、今後ともよろしくお願いいたします。
はい、よろしくお願いします。
はい。皆様どうもありがとうございました。
Thank you so much, gentlemen.
Thank
Ryan,
you so
Jamie,
much.
brilliant.
You're
Look forward
welcome.
to seeing
Thanks.
you when the borders reopen.
Yes, see you.
Okay.
ありがとうございました。Thank you so
Thank you.
much. ありがとうございました。
Thank you very much.
さよなら。